All right, we're on section 5.5, properties of logarithms. So let's take a look at the properties. So the first one, tells us, what it says up here for positive numbers and all that, that just means that each of these is a legitimate expression, okay, or a legal expression. So for example, you can't have negative arguments for logs, right, and things like that. Your a can't be 1. You guys remember that it has to be positive, and it can't be 1. All right, so the first property is self-explanatory. Log base a of 1 equals 0. Why? Because a to the 0 equals 1, right? And notice a can be any base, right? Because any number positive to the 0 is 1. All right. Log base a of a equals 1. There's two ways to think about this. You remember when you had the same base on the log and on the argument, the exponent is the answer, and this is a to the first, so the answer is 1. If this was a to the second, the answer would be 2, right? This is very important just with the log base a of a, because for example, if you have a 10 here, then you can take log of 10 and it gives you just 1. Or if you have an e, ln, natural log of e will give you 1. Okay, and those are two important ones to remember. All right. The second property says that if you have a sum of two logs, the same base, right, same base logs, if you have a sum, you can write it as a single log, yeah, but the way you do it is you take the arguments of the ones you're adding and you multiply them, right? So you're adding a log base a of m plus log base a of n, and it's a log base a of m times n, right? So you multiply the two arguments. Notice when you're adding, you have to be very careful because this actually says the coefficients have to be 1, right? There's no statement of that, but the way the rule is written, the coefficients have to be 1, right? If they're not, there's a way to fix it, and we'll look at that later. Number 3 says, what if we're subtracting two log statements? Well, you can write that as a single log statement with a division of the two arguments in order, right? So the first one, if you're subtracting the first one minus the second one, then you in the argument of the single log statement, you're dividing the first one argument minus divided by the second argument. Okay, all right, and and it also says that the coefficients are 1, right? Coefficients are 1. All right. The last one, number 4, says if you have an argument with an exponent, notice that exponent applies to the whole argument, that you can actually bring that exponent to the front as a coefficient. But we can also do that backwards. So if we see a coefficient here, we can put it up here as an exponent, which brings us back to this one. Remember, what if you had, you're supposed to have coefficients 1. What if you had a 2 right there, a 2, right? So well, you could take that 2 and move it up as an exponent, and then that coefficient would be 1, right? Because your coefficient of 2 moved up here, so it's no longer there, it's a 1. Okay, so that's a way to fix that if you need to fix that. All right, let's test our rules up here. So number 1, let's do a. And what are we testing with a? Well, we're testing that when we add two logs, you can write it as a single log, right? Which is this one up here. Yeah. So let's test the logs that we're adding. So log base 2 of 8 asks 2 to what power is 8, and that's 3. Plus log base 2 of 4 asks 2 to what power is 4, and that's 2. And 3 plus 2 is 5. Notice if you take 8 times 4, that's 32. And so is log base 2 of 32 also equal to 5? Well, 2 to what power is 32? It is 5. So they do match, right? So the rule seems to work well. All right, let's try, and we'll leave the other ones for class. Let's try number 2, evaluate 2 times the log base 9 of 3. All right, well, log base 9 of 3 asks 9 to what power equals 3, and of course we don't know, yeah? But remember, we can take this coefficient and move it up to the exponent, so we can move it up here, and this will become a 3 squared, and this will become a 1, so this will be log base 9 of 9, right? Which brings us back to this rule up here. Log base 9 of 9 is 1, or it asks the question 9 to what power is 9? 1. Okay, so notice by using this rule we could find an answer that otherwise we couldn't find. All right, we'll leave the others for class. All right, let's try number 3. Write as a single logarithm, and we'll do a and we'll leave b for class. So a, we're gonna write this sum as a single logarithm. Notice there's 3 logs. Well, we can do 2 at a time, but first, you remember when we combine into a single log statement, that coefficient has to be 1? Well, we can take that 3 and move it to the exponent. So I'm going to take this 3. It will no longer be there. It's going to move over here. This will be log base 2 of x to the third, right? Okay, now I can do log base 2 of x to the third plus log base 2 of 4x. This will be log base 2 of x to the third times 4x, right? Let's write it that way. X to the third times 4x. And of course, you know we can multiply those. Minus log base 2 of 8x. Okay? Now when we do a subtraction, that becomes a division, right? So this will be, when we combine the two, log base 2 of, and I'm going to go ahead and multiply these two. That'll be x, 4x to the fourth. 4x to the fourth over, let's put that in parentheses, 8x. Yeah. All right, and then we can simplify, right? Because we have x's on top and x's on bottom, and the 4 and the 8 reduce. This will be log base 2 of the 4 and the 8 reduce, so the bottom will be a 2, and the top, the x cancels 1x from the top, so it'll be x to the third over 2. Yeah, so we can write it that way. Okay, and we'll leave number B for class. All right. Number 4 says expand the expression, which means go backwards from what we did right there. Write your answer without exponents. Okay, so log base 7 of x squared y over z to the fifth. So this will be the division first. I can rewrite as a subtraction. Remember what we did over here? Subtraction turns into division. Division turns into subtraction. Okay, so this will be log base 7 of x squared y minus log base 7 of z to the fifth. Okay. All right. Now multiplication. Remember, addition turned into a multiplication. The addition of two logs turned into a multiplication of the arguments. So this multiplication of the arguments will turn into an addition. This will be log base 7 of x squared plus log of y, 7, log base 7 of y, minus log base 7 of z to the fifth. Now, the instructions say I cannot have exponents, so I'm going to just move the exponents down to the front as coefficients, right? Each of these. So this will be 2 log base 7 of x plus log base 7 of y minus 5 log base 7 of z. Yeah, that's our answer. All right, and a couple of last problems. Change of base formula says we can rewrite a log with a different base, right? But this is the way we do it. Whatever the base is, yeah, log base a of x, it's base a, can be rewritten as log base b of x over log base b of a. Notice there was no b in the original one, right? Where does that b come from? It comes from our own imagination, whatever we want it to be. And then we'll have a way of deciding. So the way you decide is whatever your calculator does, right? B is whatever base your calculator does. Our calculators, scientific calculators, do log base e, which is called ln, natural log, or log base 10, which is just called log. Okay, so let's do one of these. Let's do a, and we'll use log base 10, and we'll use log base e, which is ln. All right, so log base 3 of 6. Notice my a is 3, and my x is 6, right? Okay, and my b is, we'll use log base 10, which will be, this will be log of x, which is 6, over log of 3. Yeah, and that'll be some approximation. So let me get my calculator here. All right, so in my calculator, I'm going to type in log base 6 divided by, log of 6 divided by log of 3. So 6 log, that's log of 6, and then I hold it, and then log of 3, and then I'm going to divide the two, and I get 1.63, about 1.63. Okay, now I'm going to do it with ln. Okay, same thing, right? It'll be or ln of 6 over ln of 3. Okay, so if I do my ln thing, 6, take ln, keep that. 3, take ln and divide, and I get 1.63 again. To the nearest thousand, 1.631. So this is about 1.631 also. All right. So notice they both give you the same answer. Now, can we check that? Well, remember this is an exponent.